Hey guys, my name's Jacob, and I did my research paper on carbohydrate loading. Specifically, the areas of focus on carbohydrate loading, which I researched through studies, is carbohydrate loading and its effects on exercise performance, on muscle glycogen stores, and on carbohydrate metabolism. So to start out with just some carbohydrate basics, carbohydrates are digested um, down into glucose when we eat carbohydrates, and this glucose is then either used as a source of energy or it can be stored as glycogen in the muscles and the liver. Um, and this glycogen, which is stored, can later be used during exercise and other activity as a form of energy for the muscle in the body. Um, so knowing this, we can now define what is carbohydrate loading, and it is a strategy to improve athletic performance by increasing energy stores, um, or also known as glycogen, which we just went over. And how is this increase in glycogen content achieved? It's achieved by eating a high carbohydrate diet, um, and also most cases of carbohydrate loading, a decrease in exercise prior to the athletic event is administered just to maximize the amount that can be stored as glycogen. And this usually takes place 3 to 4 days before the athletic event, just in order to allow the body enough time to continuously store up glycogen in the muscle to have an excess amount of compared to normal levels. So, from the studies looked at, carbohydrate loading and its effects on exercise performance was not exactly what I was anticipating. So what it found is that there's no effect on exercise performance for high intensity activities lasting more than or less than 5 minutes, and moderate intensity jogging or cycling for 60 to 90 minutes. And interestingly, what um, these studies actually found in the moderate intensity jogging and cycling athletes was they measured their muscle glycogen stores after exercise and found that there was still a considerable amount of glycogen stored in the muscle. And this is important to realize because it can show that glycogen may not even be the primary source of fuel for the body during these moderate intensity exercises. Um, However, there was a benefit noticed, specifically in endurance athletes whose activity lasted longer than 90 minutes, where a 20% delay in fatigue was noticed. And it is important to realize with these kind of athletes and these kind of events going longer than 90 minutes, fatigue is associated with low muscle glycogen. So this is important to realize because it can help to make sense of why a carbohydrate loading dietary strategy would allow for fatigue to be delayed 20%, because a carbohydrate loading dietary strategy would increase the amount of glycogen stores or the amount of glycogen stored in the muscle, thus allowing for the body to have more glycogen to be used, which would take fatigue to set in longer. So, carbohydrate loading and muscle glycogen stores. Um, these studies found differences in gender between the effectiveness of this diet and the ability to store more glycogen into the muscles. So for men, these studies found an increase in 41% above normal values of muscle glycogen, whereas in women, there was no increase in the amount of glycogen stored in the muscles. And with this, there was possible causes that were explored. One of these being that females rely more on lipids as an energy source during exercise than carbohydrates, which is different from males who rely mostly on carbohydrates as an energy source. And what this would do would cause less glycogen to be used during exercise for females, and thus less of a need to restore these stores which had been used, which would then cause less, glycogen to be stored in the body. Another possible cause explored was that in men they observed an increase in hexokinase activity, and what hexokinase is basically an enzyme in the body which promotes the loading and storage of glycogen into the muscles. And so because men have more of this, they're able to store more and more glycogen compared to females who do not have such a high activity of hexokinase. So that was also looked at as a possible cause. Also, interestingly, phases of the menstrual cycle were looked at as a possible cause, and what they found is that in the luteal phase of the menstrual cycle, progesterone is produced 10 to 15 times above the normal rate compared to other phases of the menstrual cycle. And what progesterone does is it decreases the utilization of carbohydrates as an energy source. So this factor, along with the female reliance on lipids for energy during exercise, would also lead to a decrease in utilization and thus a decrease in the need to continue to replenish the stores. There was also a cause which was not proven, but it could be the most important cause, and that was of absolute carbohydrate intake. So in this study, there was two groups, two male groups and two female groups. So there's 4 groups in total. And one of these groups, one of the male groups, one of the female groups ate a low carbohydrate diet, and one of these groups for the male and females ate a high carbohydrate diet. And they based these diets for them off of total caloric intake. So the low carbohydrate diet groups would eat 55 to 60% of their caloric intake in carbohydrates relative to their specific calories needed to maintain their body weight, as males and female athletes are different weight and also burn different amounts of calories. Males typically burn more calories than females. And so what they found is that although relatively they were eating the same percentage of carbohydrates in their diet, in terms of absolute carbohydrates, both male groups were eating more carbohydrates than both female groups by a lot, by at least 100 grams. So, this was looked at as a possible cause as to why men were able to store more glycogen than females and show an increase where females show no increase. However, I have a question in here, and it says, is this feasible for female athletes? And I asked this question because for many of these female athletes to match the amount of carbohydrates eaten by the male athletes, the carbohydrates in their diet would have to consist of nearly or at 100% of their dietary intake, which is not a healthy way to live and is clearly not feasible. So if this is the most important cause, then female athletes may be out of luck in a sense, as in the feasibility of solving this would just not be there. So the last topic focused on was carbohydrate loading and carbohydrate metabolism. And what this study showed is that men metabolize 53.1% of their energy from glycogen, whereas women metabolize only 45.7% of energy from glycogen. Basically agreeing with the previous statement that females use lipids more as an energy source during exercise, whereas males use more carbohydrates and more glycogen as energy during exercise. However, there was a study which provided conflicting research, and in this study they measured male and female athletes again. However, they matched them up with the same exact activity level and same exact fitness level. And what they observed was there to be no difference between these athletes who were equal in athleticism and fitness to fatty acid utilization, blood glucose utilization, and glycogen utilization. And what this basically showed is that these athletes who were paired together, not by gender but by fitness level, actually their bodies used the same amount of glycogen and lipids as an energy source. There was a small difference noticed in the use of myocellular triglycerides. However, this did not result in a change in the percentage of lipids used, just in the type of lipids that each athlete was using. So to conclude our findings and just to summarize what was found, For exercise performance, the only benefit noticed was in endurance athletes whose exercise lasted more than 90 minutes, and this benefit was a delay in fatigue of 20%. For glycogen muscle stores, men increased their glycogen stores above normal levels 41% with carbohydrate loading, whereas women showed no increase at all. And for carbohydrate metabolism, there was conflicting research found, as just went over, although it appears that male athletes typically get 53.1% of their energy from carbs, whereas females only get 45.7%. However, if these athletes are matched with activity level and fitness level, it seems that the difference in gender between athletes will actually not matter, and they will use the same amount of glucose and lipids as an energy source. This being said, much more research needs to be done between carbohydrate metabolism and the difference between male and female athletes. So to conclude, some conclusions we can make from the research provided and analyzed is that carbohydrate loading does seem to be an effective method for male, and I highlight male endurance athletes whose activity lasts longer than 90 minutes, as this can be concluded because carbohydrate loading is proven to raise male glycogen stores to at least 41% above resting value, and in the actual performance during long distance events, fatigue was delayed 20%. So these two things coming into account, we can confidently say that male endurance athletes will benefit positively from carbohydrate loading. Different from this, however, is that pretty much every other type of athlete, male and female, carbohydrate loading does not seem to be an effective method. So basically, any male athlete who's not an endurance athlete, or any male athletes who don't exercise longer than 90 minutes, it doesn't seem as though carbohydrate loading will be an effective method for them. And it was observed that if you do not exercise for at least 90 minutes, then glycogen stores will actually be at a pretty significantly high number to where carbohydrate loading would not have an effect. And also, for the lack of evidence of being able to increase glycogen stores and others possible things, such as females relying more on lipids as a source of energy during exercise, it can be concluded from the present research that female athletes, just regardless of activity type or exercise, do not benefit at all from carbohydrate loading. So this will conclude my presentation. Thank you for listening, and I hope you guys learned something. Thank you.